All right, so things about your equations. All right, just like we did yesterday, you need to make sure that your equation that you're working with is in standard form, which means descending order, everything on one side set equal to 0. I really don't care, since we're doing the quadratic formula, I don't care if your a is positive, if it's negative, it doesn't really matter. When you're trying to factor, you need that coefficient on the x squared to be positive as much as possible because it's easier to factor, but quadratic formula you don't. Right. So for your quadratic formula, whatever the variable is that's in your equation, that's what you're going to use to set up your formula, because you are trying to solve for x. So because there's x's, when we write this, you have to write whatever the variable is that's going to be your variable. So if it's n, y, whatever it is. But it's always the opposite of b plus or minus the square root of b squared minus 4ac. And it's that entire thing divided by 2 times a. Yeah, you've probably seen it before. And so you have to remember that a, b, and c, those are coefficients. So if you're in descending order, it's a lot easier because order of the alphabet, A, B, C. Yep. So the other thing that you have to remember when we're dealing with the quadratic formula is going to be this discriminant right here. That's what you have underneath the radical. That radical has a bunch of different options. All right. So the best options, the ones we like the most, are when that's a perfect square. Because when that's a perfect square, we're going to get these nice little roots that can be fractions, they can be integers, they can be things like what we solve when we're factoring, which makes it a lot easier. All right? And so we're going to go off to this side. I'm just going to write some things you need to remember. You know, like if you get the square root of 0, that's 0. Same thing with like square root of 1. All right? I'm just going to kind of list some of your perfect squares you need to remember. Square root of 4. Anything in between the square root of 1 and the square root of 4 is a decimal, and so you're going to have to leave it as a simplified radical. Same thing with root 9, and so on. So these are some of your main perfect squares that you're going to have to remember. Pretty much you should know all of them up through at least the square root of 144. Because that's your math facts through 12. Right? But if you don't remember, I mean, most of you have a calculator where you can double check what the square root is. Like I said, if you come up where you're trying to find a square root and it's not a perfect square, you're going to have to simplify it down. So for example, if you have something like the square root of 48, this is not a perfect square in itself, and you're not allowed to leave it as the square root of 48. So what you would need to do is you need to look for how you can pull perfect squares out of 48. And so 48 is the same thing as what? 6 times 8. All right, well, neither of those are perfect squares, but I can move factors around. So sometimes I don't know what the perfect squares are. So I have to actually factor it out to where I can find some perfect squares. And so if I can find pairs or perfect squares, I'm fine. All right, so I know I can factor out a 2. And I also know that the square root of 4 is also 2. And so really this is the same thing as 4 root 3. All right, sometimes if you can find perfect squares, like I didn't remember for whatever reason that 48 is the same thing as 16 times 3. All right, so sometimes I don't remember those. And so if you don't remember them, you're going to have to go through and try to figure out how you're going to simplify. Same thing with if you had like the square root of, 24. I know it's 2 times 12, but again, 12 is not a perfect square. So you got to try to think about values in there that are perfect squares, like 4 times 6. And that makes it a little bit easier because then I can look at the square root of 4 as 2. And the square root of 6 has no more perfect squares, and I can simplify my radical. So you're going to have to do that for using the quadratic formula, where it's great if we get a perfect square, but if not, you're going to have to simplify the radical and pull out perfect squares. So we're only going to really have a couple of examples on using the quadratic formula. Most of it is order of operations, things you're going to have to be careful on. Right? And I'm going to give you a variety. I'm going to change up the letters a little bit. All right. So on all of these, your job is still to solve. All right. I'm still trying to figure out like what values for x make this true. So sometimes you can use factoring. Sometimes you're going to sit there and you're going to check the factoring methods and they're not going to work. All right. So you can always check it, but quadratic formula always works no matter what, whether it could be factorable or not. So let's look at x squared minus 5x minus 14 equals 0. So something where I actually know that this is factorable, and so I know what the answers are going to be for me, but I want to show you how, even if it is factorable, quadratic formula works. I always go through and figure out what a, b, and c are. All right, so I always make sure it's in descending order, all on the same side. And I personally like to write down what those values for a, b, and c are, because I tend to make mistakes when I substitute, so I like to just see it. And so the whole thing of what you're going to have to start with is whatever this variable is, that's how you're going to start your quadratic formula. So the formula says you want the opposite of b. So if b is a negative 5, the opposite is a positive 5. And then you have your plus or minus. You've got to square the b minus 4 times a times c. And in the denominator, when you do 2 times a, because a is 1, I can just write 2. And I can just do that multiplication. So I'm going to be expecting to see your setup of what the quadratic formula is, and the variable is equal to, because you are solving. And from there, you can simplify. All right. So you can use your calculator for some of this. I mean, like 4 times 14, negative is a positive. Like I said, make sure that you do the order of operations correctly. And what you get underneath the radical is a perfect square. That's going to be my happy place. All right? It's not on my list of what I wrote out, but like I said, you want to make sure you can remember everything up through 12 times 12. And so your square root of 81 is 9. So you have two options here. Either x is going to be 5 plus 9 over 2, or it's going to be the 5 minus 9 over 2. So the plus or minus is the part that you have to do as the option of, was it the positive or the negative of the root? And you're not allowed to leave your answers that way. You must simplify this down. So like 5 plus 9, that's 14. So 14 over 2 is 7. 5 minus 9 is what, negative 4? So negative 4 divided by 2 is negative 2. And so those are my two values for x that would make this quadratic equation a true statement. If you come up with a perfect square under the radical, then that means that you could have tried to do some sort of factoring technique to make this work, but maybe you just didn't see it, or it just was, I don't know, it would have taken you longer. But this is the process. Like I said, if you want to write down the a, b, and c, that's fine. If you don't, that's fine too. But you do need to write x equals and those little set notations like we did yesterday. So I'm going to change the variable a little bit, not too much. But I'm going to change it to like, I don't know, n. And I'm going to use one that has an a that's not equal to 1. All right, so 2n squared minus 3n minus 5. Again, I've wrote it specifically so that way it's already in descending order. It's all on one side. I'm going to identify my a, b, and c. So now the variable that's inside your equation is not an x anymore. So when you set up the quadratic formula, you have to write n equals, because that's the variable you're actually solving for. But the a, b, and c, the rest of it is all the same. All right, it's still the opposite of b, plus or minus. And now you can shortcut this a little bit, because if you're going to do b squared, negative 3 times negative 3 is 9. So you can do that portion first if you want to without actually substituting. But the rest of it, minus 4 times a times c, sometimes you can't do that in your head, so I prefer you to write it down. And again, 2 times a is 4. And so we can shortcut a little bit of what we're writing on the inside. But make sure that that division bar goes all the way across. Now again, if you want to use on your calculator and you want to plug in all of this exactly the way you see it, you can do that without doing it multiple steps. And so if I use my calculator, I am going to get a 49 underneath that radical. And so because that's a perfect square, again, it gives me two options. Again, either n is going to be the 3 plus 7 over 4, or the 3 minus 7 over 4. So I separate it out into the two fractions, so that way it's easier for me to figure out what it is I'm supposed to be simplifying. You need to make sure that your answers are always simplified proper or improper fractions. We usually don't use decimals at all. So this is the same thing as 10 over 4. And negative 4 over 4. But again, like, sometimes I can't do those necessarily in my head. So you need to make sure that your final answer looks like the n, and change this to 5 halves and negative 1. So simplify your fractions as much as you can. Don't leave them with common factors still left in them. Again, because eventually we want to be able to graph these, and you're going to have to simplify them anyway. So these ones are kind of more straightforward. I think the ones where you have to think about how to simplify the radicals are the ones that kind of throw people off a little bit, but I do the same process. All right, so we're going to go through the same idea as A and B for your last example, but it's going to be one where it's specifically not going to be a perfect square. Let's see, I need a different variable. I'll just use y. So as long as it's the same variable all the way through, and it goes in descending order, squareds, first power, no powers, it doesn't matter what I write there, variable-wise. Same thing. So look for your A, B, and C. And start plugging in. Again, this is going to be, I'm solving for y, so y equals opposite of b, plus or minus. All right, square the b makes it a positive 4, minus 4ac. And again, 2 times a is again 2, just because 2 times 1. Now if I look under the radical, what's going to end up happening under this radical is negative 4 times negative 2 is 8. So now under the radical, I have the square root of 12. And that's not a perfect square, and you are not allowed to write that as a decimal. You have to leave everything as simplified fractions, simplified radicals. So I'm going to separate out my two fractions still. All right. What I want to do first is I want to think about simplifying. How am I going to simplify the square root of 12? And so the 2 that's from the first part on the other side of the plus or minus is completely separate. The square root of 12 is the same thing as 4 times 3. So if I think about it as 4 times 3 under the radical, then I can see the perfect square that I'm going to be able to take out. And I'm going to see the piece of the radical that's going to have to be left when I'm done. So your radical really is the same thing as 2 root 3. Again, that's on the other side, of the plus or minus. And that denominator is supposed to be a 2, not a 3. So your fractions are a little bit different, all right? And you can do this in multiple ways, so I'm just going to show you one, and you can choose if you have a different way, it's fine. So your values for y, you either have the 2 plus the 2 root 3 over 2, or you have the 2 minus 2 root 3 over 2. And what you have to look at is you have to look at simplifying, if possible, these pieces right here on the outside. All right, so these are really two separate fractions that are put together. If you have one denominator and you have multiple terms, that's the same thing really as 2 over 2 plus 2 root 3 over 2. As a rule of fractions, that's really what it is. But we combined it into one fraction to make it less to write. So when you are simplifying these, you have to look at taking out a common factor from all three. And if that's a struggle, you need to look at it as separate fractions that you're going to simplify. So really for y, if I simplify this down, this is really the same thing as 1 plus the square root of 3. And that's one answer. That's a combination. That's what happens when I simplify this first fraction. The other option, again, is if I simplify out and I take a 2 out of everything over here, the other option is when I have 1 minus the square root of 3. And that's my other answer, because the square root of 3 is a decimal, but I can't write it as a decimal. I have to leave it like this. So if this is, like I did it this way, and that's fine, but if you're not sure, separate it all out into the separate fractions and then simplify down the individual parts if doing it this way in like the little heart is difficult. Questions, comments, concerns, things you want clarification on? Most of your homework is going to be like A and B with a few like letter C, where you got to simplify.